Hey everyone, welcome back to Cracking the GRE Math Subject Test. This is Calculus 1. We're on question number 40. So in this question we're given three integrals, and we're asked which of them converge. And this question is pretty tricky. It's not tricky, it's just you have to be good at integrals to figure it out. And so let's see, the first integral, the way to solve it is either to just remember that what the antiderivative of 1 over x squared plus 1 squared is, or if you don't remember, then you can do a trigonometric substitution. So I'll show you how to do that. Draw a triangle, the angle is theta, and then do something like 1x square root of 1 plus x squared. And then write out the relationships that you know. For example, tangent of theta is equal to x, and sine of theta is equal to x over square root of 1 plus x squared. Cosine of theta is equal to 1 over square root of 1 plus x squared. And from here, we're going to write two things. One, that theta is equal to the arctangent of x, and let's also differentiate implicitly. We'll get the derivative of tangent is secant squared theta d theta is equal to dx. Okay, so now we can make some substitutions into our integral, and we can rewrite this integral as the integral, and I'll fill in the limits a little bit later. Instead of dx, we're going to write secant squared theta d theta, and instead of x squared plus 1, we're going to write, well, actually 1 over square root of 1 over square root of x squared plus 1 is cosine theta. So 1 over x squared plus 1 is going to be cosine squared. And cosine squared is the same thing as 1 over secant squared. So we're going to have a secant squared here. And this whole thing is squared because of this square right here. Okay, so this simplifies. We're going to cancel one of the secant squareds and cancel out this exponent, and we'll end up with 1 over secant squared, which is the same thing as cosine squared. Now let's fill in the limits of integration. Remember that theta is arctangent of x, so what's the arctangent of negative infinity? Well, that's negative pi over 2. And what, in other words, which angle gives a tangent of negative infinity? So that angle is negative pi over 2. And for positive infinity, it's going to be positive pi over 2. Okay, so now we have to integrate cosine squared. And the trick here is to use our double angle identities. I'll just remind you what they are. We know that cosine squared theta minus sine squared theta is equal to cosine of 2 theta. And we also know that sine squared is 1 minus cosine squared. So this is actually going to be 2 cosine squared theta minus 1 equals cosine 2 theta. And if we solve this for cosine squared theta, we'll get cosine squared theta is equal to 1 plus cosine 2 theta. All of this times 1/2. So we can, and that's easy to integrate because if we, so now let's substitute into our integral. Negative pi over 2 to pi over 2. Instead of cosine squared, we have 1/2, which can come out in front, times 1 plus cosine 2 theta d theta. Okay, well, this integral is going to equal theta plus, there's a 1/2 out front, theta plus Cosine of 2 theta, that's going to be sine of 2 theta divided by 2. And we're going to evaluate this from negative pi over 2 to pi over 2. Alright, if we plug in pi over 2, we're going to get pi over 2. Actually, at this point, we could have stopped because it's pretty clear from this result that the integral converges, but let's just figure out what it is anyway. So we're going to have pi over 2 plus sine of 2 times pi over 2. Well, that's sine of pi, which is just 0. So that drops out. And then minus negative pi over 2. I'll write that here. Plus sine of 2 times negative pi over 2. That's going to be sine of negative pi, which is also 0. So that's going to drop out. So we get pi over 2 minus negative pi over 2 times 1/2. That's going to be 2 pi over 2, or pi over, and then times 1/2. So this is all going to end up being pi over 2. So 1 definitely converges. So that's good. So let's move on to number 2. This integral, we're going to have to do by parts. And let's move to a different color. So this integral, let's say that u is equal to x and dv is equal to e to the negative x. Then du is equal to dx, and v is going to equal negative e to the negative x. And remember, with integration by parts, the integral of u dv is going to equal uv, which is x, negative x e to the negative x, minus integral v, so that's negative and negative, we're going to make a positive e to the negative x, du, which is dx. And now let's evaluate this integral. So this is going to equal negative x e to the negative x plus the integral of e to the negative x, so that's going to be minus e to the negative x. And this we can factor out an e to the negative x, and we'll get negative x minus 1. And we have to evaluate this whole thing from 1 to infinity. Well, at infinity, we'll get e to the negative infinity, which is 0, and negative x, which is negative infinity. So that's like 0 times infinity. That's actually an indeterminate form. You could use L'Hopital's rule, but it's kind of not hard to see that e to the negative x goes to 0 much more quickly than x goes to infinity or negative infinity. So this is going to be 0. So this is going to be 0 minus, and when you plug in 1, you get e to the negative 1, which is 1 over e, times negative 1 minus 1, which is negative 2. That's actually going to be a plus 2. So our answer is 2 over e. So that converges. So now we just have to check the third integral to see if it converges. Well, this one, let's do it up here. If we make a substitution of u equals 2 minus x, then du is going to equal negative dx. And then we can write the integral as negative du all over u squared. And the limits of integration, well, when x is 0, then u is going to be 2. And when x is 2, then u is going to be 0. Okay, so if we integrate this, we'll get, I think it's going to be negative 1 over u. So that's just going to be a positive 1 over u. Right, because u to the negative 2 is going to be u to the negative 1 divided by negative 1. And that's going to cancel with that negative. So we get 1 over u from 2 to 0, which is like 1 over 0 minus 1 over 2. And that definitely diverges because of this 1 over 0. So this is not going to converge. So our answer is 1 and 2 only, which is B.